Welcome to qnawire.
Okay, so we know the stagnation temperature can be equal to T plus V squared over 2Cp. So therefore T can be equal to T0 minus V squared over 2Cp. So we know the stagnation temperature is 700 degrees Fahrenheit. If we convert to Rankine, it's about 1160 Rankine. And the velocity squared, which is 900 feet per second to the power 2. If we convert it to the British thermal units per pound mass, it's about 32.3521 British thermal units per pound mass. The reason why I need to convert it to British thermal units per pound mass is because our goal is to determine the static temperature, and the unit for the static temperature in this case is either degree Fahrenheit or Rankines. Okay, and the only way to get the unit Rankine is use the British thermal units per pound mass divided by the units of the specific heat, which is British thermal units per pound mass times Rankine. Okay. And then we know the specific heat for the steam is about 0.445 British thermal units per pound mass times Rankine. If you take a look at the table A2E, which is the ideal gas specific heat of various common gases. And then we can just plug in these values back into the equation to determine the static temperature. So the static temperature, which is T here, can be equal to 1160 Rankine minus 32.3521 British thermal units per pound mass over 2 times 0.445 British thermal units per pound mass times the Rankine. And this will give us the temperature is about 1124 Rankine. If we convert to degree Fahrenheit, it's let me see, 664 degree Fahrenheit. So this is the value for the static temperature. So now let's try to determine the static pressure, which can be expressed as P0 divided by T0 over T to the power of K over K minus 1. So we know this stagnation pressure is given as 120 psia, and the specific heat ratio is 1.329. If you take a look at the table A2E, you'll find out. And then the temperature, which is the static temperature here, we know is 1124 Rankines. So now let's plug in back to the equation to determine the static pressure, which is equal to 120 psia divided by T0 over T, which is 1160 Rankine over 1124 Rankine, and then to the power of 1.329 divided by 1.329 minus 1. And this will give us the static pressure is about 106 psia. And these are the answers for this question.